Hey there, everybody. Welcome back. This is going to be on 6.2. This is just going to be the lecture part. I'm going to just, without really a big example, we're going to find volumes now. And this is, we're doing actually here volumes by slicing. And this is a disc washer method. So to motivate this as like volume, let's just say we had a cube, or a cube, not a cube, a box. And rather than looking at a side angle, I'm just going to look at it like this. And we have like depth going into the page. So if I wanted to integrate this, I would go from A to B. And now, like, I'm going to have a delta X there. But if I look right here, like look at what it means over here, that's like this box right here. So it's not just a rectangle, it's like the height is really area here. So we'll call it AX. So what we're really looking at, like, and that's like if we pick some like XK star element here, like, so this will be the volume. The volume would be volume of, like, I'll call it K star because that's where we're at. There's going to be A times XK star times the width times delta X. That's for one specific rectangle. And then if we integrate from A to B, we have area of X times dx. So the example I want to do, we're going to show it the way we know how to do it. We'll just do it here. Let's look at the area of a cone. Volume, not area, but volume of a cone. So like, how could I make that? Let's just have like, so I'm going to have a cone like this, and I'm going to have it going like the x-axis is right down the center. So this is like a radius r and a height h. So right, if I wanted to do this line right here, this is y equals r over hx. So I can generate this cone by making that rectangle right there with this as being y equals r h over x and rotating it around the x-axis. Okay, so like that's our line. And I'm gonna like slowly rotate it around the axis. When it gets down to here, we're at the bottom, and we keep going and it circles back around until we get to the top. A vertical view is like this, but we've got this. And so like, remember, this is the cone we're doing, but looking at it all 3D like that, it's a little hard to see. So we're gonna look at it over here. So that's what's kind of, we're doing it like that. Okay. So if I like make a wedge here, we're doing AX dx, remember? Well, the disk washer method is done by rotating things around an axis. This makes a circular region. I have a disk here. I've got the DS. The area of that, it's a disk though. The area of the disk is pi r squared. But what is r here? It's not the big R here. It's this R right here, which is y. This is like pi y squared. Okay. So here, if I'm setting up the integral, this is going up to h. We said that here, showed that here. This is a length h to right there. And that makes this a height r there. If we're going along dx, we're going from 0 to h. We want the area. We want the area of pi y squared times our dx. But these are in terms of the same variable. So we got to make them in terms of the same variable. So 0 to h pi, this is my y, r over h x squared dx. So I get r squared over h squared, and we'll have a pi on top there. We're going from 0 to h of x squared dx. Times 1/3 x cubed from x equals 0 to x equals h. These two cancels out two of those. We're just left with a 1. And we're left with pi r squared h as the volume of a cone. Okay. The washer method, we'll do some examples in class, but the washer method involves maybe, I'm just going to sketch it here, but we're not going to do a full problem. Like, let's just say I had like the waffle cone part of the ice cream cone. So like, let's say I've got this, like I've got a width here. This is my waffle cone. And so like, this is the waffle cone. And now when we're doing our disk method, if you look at its side profile, this is really what's going on. We're looking at like a rectangle here, but the one area we want is this part rotated around. This is making, from overhead, it's making a ring with a thickness of dx. So how do we do the area? This is called a washer because it looks like a, it's screw and washer and stuff like that. How do we do the area? Well, we can do pi of the outer circle. Let's say the outer circle is radius big R, and the inner circle is radius little r. We can take the big circle's area and subtract the little circle's area. And that way we get a washer. So pi r squared minus pi little r squared. And we can factor out the pi. We've got r squared minus r squared. That's what's going to happen on the washer method. So in this case, if we were again doing like the cone, remember this was H, how we'll finish it. We called them R. We're doing volume. We're going from 0 to H. We want the area of that washer. The area of that washer is this. And we don't know what these, like it's not R squared. That would be at the end. So this is like, if we call this line here f of x and this line here g of x, this is like pi times f of x squared minus pi times g of x squared. We already saw the formats of these lines. It was y equals r over h x. So like on the fx, we had capital. R squared over h squared x squared minus pi times little r squared over h squared x squared. These both have a dx on them, so I need parentheses. I can factor out a pi over h squared. And in here, I can like pull out the x squared and write it like that. So the volume of this cone with like an outer radius of r right here, that's r. And this little inner cone, the inside of the waffle cone is little r. We have upper power divided by power. I've got pi h squared times 1/3 r squared minus r squared. This is x cubed. We're going from x equals 0 to x equals h. Doing that last one. What happened to my 3? Oh shit! I gotta go back. We'll do it. Go back in a second. I fucked that up. Shame. Shame. So we got, when we plug in h, 0 is going to make it go away. We've got pi over 3h squared times big R squared minus little r squared times h cubed. We end up with pi over 3 r squared minus little r squared h. Okay. Before I finish this video, I'm going to bring back a page we had before over here. I had this. When I integrated this, I screwed up. I raised this to a 3, but I didn't divide by a 3. I should have a 3 out there, which puts a 3 here, which makes this a 3. So pi over 3 r squared h. That's the volume of a cone. Okay. That's it for the disc and washer method. Peace.